Praise and thank thee that you are King of creation, that all things have been made by thine own precious hands. Help us this evening, we pray, to appreciate what you have done for us in granting us this unique place in the universe, this little speck of dust called the earth. Lord, truly, what is man that thou art mindful of him, and the Son of Man that thou hast visited him? So, Lord, we ask and pray that you put thy wisdom in our inward parts so that we may know thee and thy ways to us more plainly. Speak to our hearts now, we pray, as we go through this session and prove that thy universe is young, and that the earth is young, and that thy word is true from the beginning. Lord, just open our eyes, we pray. Lord, we pray that you speak to us and to our hearts. In thy precious name we ask it. Amen. Right, we'll just briefly outline what we propose to do tonight. We'll be speaking about, first of all, the evidence for a young earth. We'll talk about the age of the atmosphere, the age of the oceans, the age of the rocks, the age of the earth's core. Then we'll talk about, very briefly, the evidence for an old earth. And then we'll be presenting Mr. Dodwell's work on the flood, showing how the flood actually occurred astronomically. Then we'll talk about the age of the solar system, beginning with the age of the moon, the age of Jupiter, the age of Saturn, the age of the comets, and then we'll have a brief discussion about the proposed origins for the solar system and show how each one of these failed. Then we'll be talking about the age of our galaxy, with the clusters of stars of the various sorts, and the evidence for an old universe with the clusters of galaxies themselves. And then we'll be talking about the speed of light, the change in the speed of light, and how this completely answers all of the problems with radiometric dating, the distance that light has travelled and so on. So if we can begin then, Peter, with the first slide. The Earth is a unique place in the universe and in the solar system. It is the only place in the solar system in which life has been found. They've sent probes to many planets and are very interested in the planet Mars. But the Voyager probe there to Mars failed to find any sign of life, whatever. Mars is just a barren desert with wind-swept rocks. It's a very, very uninteresting place. So the Earth is unique. That's the view of the Earth from space, our own home planet. The angels sang with joy when God laid the foundation stone for that Earth, because they knew that God had a special plan for it in all that he did in the universe. So the first thing that we come to as we approach the Earth from space is its atmosphere. And can we have the next slide, Peter? There we have the layers of the atmosphere, as you can see plainly illustrated there. There's a whole host of them. And radiation from the sun and cosmic rays come in from outer space down here. They interact with the atmosphere and form neutrons. Now these neutrons plough into the nitrogen atoms in our atmosphere. And nitrogen is made up of 7 protons and 7 neutrons in its nucleus. It's called nitrogen 14 because it's 7 plus 7. And when the neutrons plough into the nitrogen, a reaction takes place which changes nitrogen 14 into carbon 14. The carbon 14 has 6 protons and 8 neutrons in the nucleus. We can have the next slide, Peter. Now carbon 14 is unstable. It's radioactive and it decays. Here you have an illustration of what is meant by a half-life. On a straight decline basis, as given by this candle, you have the half of the candle burned out and then another half burns out straight away in the same time. But with carbon-14, with all the radioactive elements, this is not the case. As you see on the far side there, if you have a lump of carbon-14 up here, after so many years, half of it will have decayed. 5730 years, in fact. Actually, that age has been updated. It's 5760 now. The half-life is getting longer. Probably a bit more about that later on. But after 5730 or 5760 years, the remaining half of that half decays. And after another 5760 years, a half of that half decays again. Okay? So this is what happens. If you draw this graphically, you have it coming down in a curve like so. This half-life is the time that it takes for a lump of carbon-14, if you had, say, 2 kilograms of it, to decay into 1 kilogram. And this is what is called a half-life, and it's an exponential decay. Here is the exponential decay curve for carbon-14. That's what the curve actually looks like. This is Professor Libby, who discovered the decay of carbon-14. He's using the radioactive dating method here to date some material from Bible times. Now, the way that we measure age with carbon-14 is this. Carbon-14, of course, in our atmosphere, combines with oxygen to form carbon dioxide. And as we breathe, we have carbon dioxide breathed in from the atmosphere. And these radioactive atoms come to reside in our bodies. And of course, after a certain period of time, some of those radioactive atoms are going to decay. But because we're breathing, it means that we're going to have a continual supply coming in. And an equilibrium position is reached where our bodies are in complete equilibrium with the carbon-14 in the atmosphere around us. And so when we die, or when something which is living has died, by no longer taking carbon-14, the carbon-14 starts to decay. And you can measure the amount of carbon-14 which is left. And from that half-life period and from that graph, you can work out how long it was since that thing died. After a long time, most of the carbon-14 would have completely decayed away. You'd only be left with a very, very small amount. Now, can you understand all that? Is that quite plain to you?
Yeah, say it again, but very slow.
You can work. The assumption, of course, in all of this is that there is an equilibrium position in our atmosphere, that the number of carbon-14 atoms being formed is the same as the number of carbon-14 atoms decaying. And Libby, Professor Libby, had been told that the Earth was thousands of millions of years old, and that the calculations showed that with the atmosphere as it is today, it should only take about 30,000 years for the carbon-14 ratio, carbon-14 to carbon-12 ratio in our atmosphere to reach an equilibrium value. And he thought, well, 30,000 years is no time at all, geologically speaking, so the ratio should have stabilised. But then as he did some calculations and some measurements, he found out, in fact, that the production rate of carbon-14 was, in fact, 20% above the decay rate. And, in fact, more recent measurements, more accurate ones, have shown that it is, in fact, 31%. Carbon-14 is being produced 31% faster than it's decaying. In other words, the equilibrium value has not yet been reached for our atmosphere. Now, Libby was horrified. He mentioned all this in his book Radiocarbon Dating in 1955, pages 5 and 7. And as time has gone on, the situation has worsened. It hasn't got better. This equilibrium value very definitely has not yet been reached. And so it means that all the carbon-14 dating which has been done on archaeological work is going to give dates which are systematically too old. Dates systematically too old. Bear that in mind whenever you see a radiocarbon dating for a fossil or a skull or something like that. These dates are always going to be too old because this equilibrium value has not yet been reached. There was less radiocarbon back in the time when the fossil was formed than there is today. And so they're going to give a value which is systematically old. And as you have a look at your calculations, if you find that it's coming in 30% faster than it's going out, it means that the atmosphere is less than 10,000 years old. The atmosphere is less than 10,000 years old for this situation to have occurred. This is positive proof from science that the atmosphere is young. We could talk about helium in our atmosphere formed by cosmic rays. Exactly the same situation applies. I've been talking about the missing helium. It's called the mystery of the missing helium. Where is all the helium coming? Where is it going to come from? Because it's just not there. After 4,500 million years, we should have had much more helium in our atmosphere than we have by the action of cosmic rays. But it's just not there. And using this helium dating as well, you get to an age of the atmosphere approximately 10,000 years old. Two different methods giving exactly the same result. The atmosphere is young. Now the important point is this. If the atmosphere is only 10,000 years old approximately, what about the life on this planet? We breathe air. If the atmosphere wasn't here 10,000 years ago, there couldn't have been any life here 10,000 years ago either. And so obviously all life and all fossils must be less than 10,000 years old. But we'll have a closer look at that fossil question a bit later on. Let's move on to the age of the ocean. Can we have the next slide, please? Right. Cosmic dust comes in from outer space. This is a rather large fragment from outer space. It's a meteorite. This is probably one of the larger varieties that come in. I wouldn't like to be hit with that on a dark night. But in addition to these large chunks, there's a whole host of very fine chunks which filter down, smaller than grains of sand. They're not burned up because they're so fine. They just drift down through our atmosphere. They get a little bit rounded off as they pass through the atmosphere, but that's about all. Now, using satellites, you can actually detect the number of impacts of these tiny little bits of cosmic dust, the number of impacts per second and their strength. And you can work out the number that should be hitting the Earth every day. And as you do this, you come to some rather astounding things, some rather astounding facts. For example, the Swedish geophysicist Hans Pettersson calculated that there would be 14.3 million tonnes of cosmic dust hitting the Earth per year. 14.3 million tonnes. This was in Scientific American, February 1960, page 132. Now, if you do some calculations on that, depending on what density you assign to your cosmic dust, you end up with a dust layer of 107 feet up to 965 feet in 5,000 million years. And astronomers agree that the cosmic dust was much thicker in the past than it is today. So that figure should be increased. But obviously we haven't got this dust on the Earth. What's happened to it? We have our next slide, please. Water coursing over the surface of the Earth with the rainfall and so on goes into rivers. It washes the dust into rivers, and the rivers wash it into the oceans. Now, if we start off assuming that the ocean water was absolutely pure water with no salts of it in it of any kind, we can make some calculations. We choose a mineral which is rare on Earth, but a mineral which is very prevalent in cosmic dust, and it's the mineral nickel. We measure the amount of nickel in the runoff in the rivers, and then we turn to the oceans on our next slide and see how much nickel there is in the oceans and the deep sea sediments, because of course some of this is just going to go straight into the sediments and not be held in suspension at all. And when you do this, you find that if 4.5 billion years have passed since the formation of the Earth and the ocean floor should be covered with nickel. In fact, there should be 960 pounds of nickel for every square foot of ocean if the Earth is 4,500 million years old. In fact, as you have a look at the amount of oceans in the deep sea sediments, amount of nickel in the deep sea sediments and suspended in the oceans, you find out that the rivers could have supplied all of that in 8,900 years. 8,900 years. The oceans are therefore young. Very young. So both the atmosphere and the oceans are young. And in our next slide, we have two rivers meeting. Here you have the Colorado, the blue Colorado, and the genuine Colorado. That's where it gets its name. Colorado means colour red. The Colorado, the colour red river. Here's the blue Colorado. Here's the red Colorado. And you can see all the sediments which are being carried down there. Silicon is probably the most common element in the Earth's crust. Uranium is probably one of the rarest. Both of these can be accounted for in the oceans by the runoff in the rivers in approximately 10,000 years. The oceans, therefore, by all accounts, are less than 10,000 years old. It means also that all fish life, everything that lives in the oceans, must also be less than 10,000 years old. So we have an atmosphere which is less than 10,000 years old, and oceans which are less than 10,000 years old. Let's have a look at the age of the rocks, see if they bear up to the same treatment. Next slide, please, Peter. There you have a geological column. Geology says that fossils in rocks are millions of years old. Here's a typical geological column. You have the Cenozoic, the Mesozoic and the Paleozoic era, and then here's the Precambrian era down here. These are the basement rocks. Actually, these basement rocks down here probably were formed at the time of creation. They haven't got any fossils in by and large. Now, I want you to notice particularly two periods here. There's the Cretaceous, which is 120 million years according to geological timescale, and also the Cambrian, which is 600 million years old. The Cambrian is right here at the bottom of the geological column. The Cretaceous is some way up here. In this period here, we had the dinosaurs living. Okay, so let's have a look at our next slide. This is a slide of the Paluxy River bed in Glen Rose in Texas. Here's the river over here, up in the top left-hand corner. And here's dinosaur tracks all the way across the riverbed. And in addition to those dinosaur tracks, the dinosaurs were there. They date that sequence as 120 million years old. In addition to those dinosaur tracks, next slide, surprise, surprise, here's our dinosaur. What's that? Can't be anything other than a man's footprint. Man and dinosaur coexisting. Incredible. As I said this afternoon, one geologist, when confronted with that evidence, said, if I believed the evidence before my eyes, I'd throw up geology and take up truck driving. It's just too incredible for an evolutionist geologist to accept. I'd rather hang on to a long evolutionist timescale than admit that the timescale is short and that a creator has made all of these things. In fact, one high school teacher down in the western suburbs of Adelaide was approached to have a look at some creationist literature with evidence for creation. He said, I don't want to accept your literature. He said, if there's any truth in what is said in there at all, it will force me to accept a creator. And that is an issue I do not want to face. That is the philosophy of science. Now, in addition to man's footprints, there have been the footprints of children there, found in that same riverbed. Okay, Pete, next slide. And the footprints of giants. There you have the giant print. An ordinary man's footprint, foot beside it, and the giant print there plainly enough. Each print about 18 inches long. And the Bible says there were giants in the land in those days. There is indisputable evidence. Indisputable evidence. And it's just not an isolated track here and there. There's whole sets of dinosaur tracks and whole sets of human tracks across that Paluxy riverbed in Cretaceous limestone. And evolutionist geologists have said, oh, well, they're just clever carvings. And so the Institute for Creation Research set a camera rolling and called in a bulldozer because the tracks went under a rocky ledge. The bulldozer stripped off the rock ledge, and lo and behold, the tracks continued on underneath. They just couldn't have been carvings at all. If we have a look at our next slide, this is the photograph of the Big Indian copper mine, 35 miles south of Moab in Utah. It's Cretaceous sandstone in the Dakota Formation, and here you have the quarry is about 15 feet deep, and the last, actually it's a bit deeper than that because the last 6 feet of that is 15 feet plus 6, 21, and the last 6 feet of that had to be bulldozed out. And just after they'd bulldozed out, some prospectors and fossickers came along, and they found some bones, which looked remarkably like human bones. The prospector and Dr. J.P. Marwitt, an anthropologist from the University of Utah, uncovered 2 complete human skeletons in that Cretaceous formation, supposedly 120 million years old. 2 complete human skeletons. Dr. Marwitt positively identified them as Homo sapiens. There could be absolutely no question about it. The bones were deeply stained with malachite, which is an ore of copper. It had almost been changed to become a copper ore. They were so deeply stained. And the rock strata continued right through the bones. The bones were put there at the same time as the strata were laid down. The bones were definitely in place. They were buried at the same time as the rock was formed. So you have definite proof that man and dinosaur coexisted in Cretaceous times, which supposedly was 120 million years ago. Our next slide is not the best, but we'll have to do. This is an iron pot which fell out of a lump of Triassic coal. Triassic coal is dated about the same period of time, about 120 million years by geologists. And yet an iron pot, obviously man-made. Hasn't been brought there by a spaceship. Certainly not. No, it's man-made. Out of a lump of Triassic coal. Therefore, man existed when the Cretaceous was formed. Therefore, the Cretaceous strata are not 120 million years old because, as everyone agrees, man is far less than 120 million years on this planet. Next slide shows William J. Meister, a rockhound. His favourite fossils were trilobites, and trilobites can only be found in the Cambrian period. That's that very bottom one which I showed you in that geological column, 600 million years old by evolutionist geologists. And trilobites were this man's pride and joy. He went round hunting for them. And he found his trilobites in the Cambrian Formation, in some cliffs. What he did, he climbed up this high cliff and whacked off this 2-inch thick lump of rock, and it opened up like a book. Along with his trilobites, surprise, surprise. Next slide. A man's sandal. Here's the heel, across there. Here's the toes projecting over the edge. And here's the trilobite fossil, there in the heel. Just in case you don't think it's a trilobite, we'll have the next slide. There it is. There's your trilobite. Man's footprints in the Cambrian. Well, William J. Meister called in Dr. Clifford Burdick, consulting geologist, to see if he could find anything else. And we'll have our next slide. That's what Dr. Clifford Burdick found. It's enlarged there, but that's a child's footprint. The footprint of a barefoot child in the same strata as those sandal prints, and in the same strata as the trilobites. And be absolutely no doubt about it. And William Meister had this to say. He wrote the following words. He said, "I had previously been little concerned with the controversy about evolution. But," he said, "since my discovery of a shod and obviously modern human footprint, this has completely turned me to the story of the Bible." He said, "In no other way can I account for this astounding discovery. It can only be through Noah's flood that this has happened." That was that man's testimony. I hope it's going to be the testimony of everyone here tonight, that these geological ages and the geological column can only be as old as man, and therefore can only have been formed at the time of the flood. All fossils are only as old as mankind, therefore, and the present human population, all scientists agree, have got here in less than 10,000 years. Well, let's have a look at the Earth's core then. We've had a look at the atmosphere, we've had a look at the oceans, we've had a look at the rocks. What about the very core of the Earth? Is there any proof that that too is young? And we begin by going out into space again. You can have our next slide here. The Earth has a magnetic field. Cosmic rays from the sun and the solar wind are deflected, as you can see, by this magnetic field. It shields us from harmful radiation. There's this sort of bow wave shock right in front on the sunward side of our planet. And it tapers off to a long tail, millions of miles long, on the other side. There perpetually. The Lord's put it there for a very good reason. It shields us from all of this harmful radiation. Now, this magnetic field is caused by currents in the core. If we can have our next slide, Peter. The Earth behaves as if it's a massive bar magnet with a north and south pole. But the temperature in the core of the Earth is so hot that all iron would lose its magnetism anyway. So you have to account for the magnetic field in some other way. Now, some of you may be familiar with this from physics, but when you pass an electric current through a wire, a direct current through a wire, it has a magnetic field around it. You can bring up a magnet to this wire, and you can bring up a compass to the wire, and you can see the compass deviate. The proposal is that these core currents are produced in the iron of the core by the decay of electrons and so on. You've got a current here in the core which is freely decaying. Iron is a good conductor of electricity. Where this current came from originally, no one is sure. Obviously God has put it there. But you've got these freely decaying currents there in the core. Now on the next slide, Sir Horace Lamb in 1883 showed that freely circulating currents must also decay because they're losing energy through heating. And as they decay, the magnetic field weakens. So there on the left you have a strong magnetic field in 1835, and in 1965 you have a much weaker field. This in fact is exactly what has been discovered. If we have a look at our next slide, you have values of the field strength. Beginning up here with Gauss, 1935, the magnetic field in amps per square metre is down here. As you can see, it starts off with 8558 down to 8.017. And there's a systematic decline in the Earth's magnetic field over the last 150 years. We can have our next slide, Peter. Dr. Thomas Barnes of University of El Paso in Texas did a computer study on this magnetic field, on those values, to see what sort of behaviour it had. And it turned out it was decaying exponentially, in somewhat the same way that radioactive carbon decays. And it had a half-life of 1400 years. In other words, every 1400 years, the strength of the magnetic field dropped to half of its original value. As Professor Thomas Barnes had a look at this, he did some calculations and pushed things back into the past, as shown on our next slide. Back at 8000 BC, the magnetic field was as strong, must have been as strong as a magnetic star. Now the magnetic field in a magnetic star is maintained by thermonuclear reaction. No one proposes that that's what's happened to the Earth. That's how strong the magnetic field must have been as you go back in time. If you go back 50,000 years before Christ, it was as strong as a pulsar. If you go back only 20,000 years, you find that the heating due to the dual currents in the core would have separated the core from the mantle. And down here about 1 million BC, the heating would have been so strong that the Earth would have been completely molten. Now this is taking things to extremes. The only logical one for a maximum is this one here, the magnetic star. It can't be anything more than that. And the date given by Professor Thomas Barnes for that was 8000 BC, just 10,000 years ago. The Earth's magnetic field is less than 10,000 years old, and because it's caused by currents in the core, it means that the core itself must be less than 10,000 years old, because there is absolutely no way in which those currents can be maintained. No way whatever. So if the atmosphere, the oceans, the rocks, and the core are all less than 10,000 years old, the obvious conclusion is that the whole Earth is less than 10,000 years old. Can't come to any other conclusion. What's the evidence for an old Earth? Firstly, as shown on our next slide, is these massive erosion remnants. People say it will take millions of years to erode rocks down like this and to form mature features on the Earth's surface. But erosion and transport the continents into the oceans in 14 million years, even at the present rate. At the present rate of wearing down the continents would have been eroded right down to sea level in 14 million years. Geologist Stuart Nevins pointed that out in the October 73 issue of Acts and Facts. 14 million years is a long time. But that's just using the processes that we have today. If we take a flood, a universal flood, with massive quantities of water transporting millions of tons of debris per second, you can account for your erosion features in a very, very short time. Actually, in a matter of days. Next slide shows a geological section through the Grand Canyon. You have the Bryce Canyon, the Zion Canyon and Grand Canyon down there at the bottom. That whole section of sedimentary rock is about a mile in thickness. It's either going to take a long, long time for a mile of sediments to build up, or it's going to take a lot of water. That's the question. You only need a long time or a lot of water. Which choice are you going to make? On the basis of Scripture. The Scripture says, and thy word is true from the beginning, as the psalmist said. The Scripture says that there was a massive worldwide flood which supplied the quantities of water that we require. The only other evidence for a long age is perhaps exhibited by our next slide. Here is a prospector having a look at some carnotite, some uranium ore. You've got a Geiger counter there. Radiometric ages, radiometric dating seems to indicate that the Earth is thousands of millions of years old. And scientists around the world are pinning their hopes to radiometric dating. As we'll discover a little later on, even these are quite unreliable, but there's some factor which will bring in, it's actually the change in the speed of light. We'll show how this actually changes the half-life of your radioactive elements. And so we'll leave this radiometric dating bit until just a little bit later on. But we'll see what evidence there is now for the flood, for a massive worldwide flood. The evidence which has been presented came originally from Mr. Dodwell, the government astronomer here in South Australia. Here he is at the telescope at the Old West Terrace Observatory. Those who knew him said that he was a saint of God. One gentleman that I spoke to said he reminded him of one of the Old Testament patriarchs. He was a Christian. And he asked the Lord to guide him into some avenue of service for the kingdom of heaven, even as an astronomer. The Lord very graciously led him, just through a series of circumstances, to study the changing tilt of the Earth's axis. By the way, he's not any university dropout, this man. He was chosen by the Commonwealth of Australia to represent Australia at the International Astronomical Conference in Rome in 1922. He was the pride and joy of Australia in the field of astronomy. All right, Mr. Dodwell studied the changing tilt of the axis. The next slide shows the variation of axial tilt. Now, it may surprise you that our axis has actually changed its tilt over a period of time, but this is nothing new to astronomers. Because of the pull of the sun, moon and planets on our equatorial bulge, the axis should trace this curve over a very long period. Here we have tens of thousands of years. It comes from about 22 degrees down to about 24.5 degrees. Mr. Dodwell had a look at the observations. This is the line of observations down here. Here's the last point in the observations. 25 degrees. Something has obviously not been taken into account by Stockwell's formula, as exhibited there. To have a closer look at what's going on here, we'll have a look at our next slide. It shows you Newcomb's formula for the changing tilt of the axis. Thanks, Peter. This is the actual curve of observations coming down here. At this date, the year 2345 BC, an easy one to remember, at this date that curve became vertical. And the axial tilt must have been something like 28 degrees. To discover the nature of this curve of observations, you have to get rid of the effect of the pull of the sun, moon and planets, which is given by Newton's formula. And to do that, we'll have a look at our next slide. There it is. This essentially is Newton's formula along here. And you have this curve, a logarithmic sine curve, which is the curve traced out by a spinning body such as a top or a gyroscope disturbed from its equilibrium. If you give a top or a gyroscope a push and it heels over, then it comes back to its new position of equilibrium, this is exactly the sort of curve that it's going to trace out. In other words, the Earth's axis had a massive change of tilt, something impacted with the Earth at this date, 2345 BC, swung it right down, and then it's come back to its new position of equilibrium, as we have it today. That curve actually latches onto Newcomb's formula curve at 1850 AD. Mr. Dodwell studied the observations a little bit further, subjected them to what's called a least square analysis to see if there's any other systematic effects, and there was, as shown by our next slide. There's this oscillation around the new mean position. And so when you put all of that together, as we show on our next slide, there's a complete curve describing the axial tilt of the Earth for any time in the past, down to 2345 BC. Now, have we got any proof that this is correct? Well, yes, we have. We look at Stonehenge. Stonehenge was a monument oriented to the sun, to the midsummer solstice. And there's always been controversy between astronomers and archaeologists as to the date of Stonehenge. The archaeologists say it was built in Druid times, roughly, say, 300 to 400 BC. Astronomers say nonsense. From Newcomb's formula here, which describes the tilt of the Earth's axis, we know it must be something like 18 to 1900 BC. And there's been this battle going on. But if you take the tilt of the Earth's axis as given by Newton's formula, which is in 18 to 1900 BC, and bring that across to Mr. Dodwell's curve, it shows that that was the tilt of the Earth's axis in 400 BC. In other words, you've harmonised completely two different areas of science which have been at loggerheads. Mr. Dodwell's curve stands the test. So what does all this mean? We'll have our next slide. This is a slide of the Mare Orientale basin on the moon. What's happened there on the moon is what's happened on the Earth. There's the impact of this massive object in the Pacific Ocean basin in the year 2345 BC to change the Earth's axial tilt. The amount by which the tilt has been changed is probably about 18 degrees. Mr. Dodwell got that from the moon. The scripture says in Psalm 89, I think it is, that the moon is a faithful witness in heaven. The moon is the odd one out in our solar system. All the moons around all the planets in the solar system always move in the plane of their planet's equator. So it's like on the top of a table, you've got the planet sitting there with its equator right sitting in the centre of the table, and on that same flat plane, all of the moons move around their parent planet. Our moon is the odd one out. It's offset from our equator by about 18 degrees. As a consequence, Mr. Dodwell assumes quite rightly that's about the amount of change which our axis has undergone as a result of this impact, which means that originally the Earth's axial tilt would have been about 5 degrees, something like that, before the flood. This would of course account for entirely different weather conditions, with this vapour canopy which I mentioned this afternoon, that vapour canopy around the Earth. You would have had subtropical conditions right over the whole Earth. In fact, in the Time Life book entitled The Weather, they showed the Earth, a proposed model for the Earth, in which the axis was almost vertical. And they said under these conditions you would have an entirely different atmospheric circulation pattern. You'd only have one massive cell coming from the pole down to the equator. And under these conditions, gentle winds would be continually blowing, equator winds. This is the sort of conditions which existed prior to the flood. They presented it as a hypothetical model. The scripture makes sure this was what happened in actual fact. So what happened? You had this axial tilt change by 18 degrees, impacting the Pacific Ocean basin. Imagine what happened. Here's the Earth, here are the oceans. As the object impacted and swung the Earth's axis over like so, the Earth heeled over, the oceans tending to remain in the same spot, mounted up over the land as a massive tidal wave, mile tide. In addition, with that impact, you would have had thousands of millions of tons of debris thrown up into the atmosphere, as well as a lot of steam from the ocean that was there. This debris would have acted as little nuclei on which the vapour canopy could condense, and the whole thing would come down as massive pouring rain. This is exactly what the scripture says happened. For 40 days and 40 nights, you had this rain pouring down. The vapour canopy came down. In addition, because of the impact, it would have buckled in the Earth's crust and tore it apart in other places. You would have had set up the plates on which the continents are moving at the moment. This is when they would have formed. And as you have a look at the moon, what happens with a massive impact there, because craters on the moon and the Mare Orientale basin is essentially just a big crater. What happened there on the moon is that with the impact, you have this initial circular basin surrounded by a series of ring folds. In other words, it's like a fold pattern set up in a pond as you drop a pebble in it. You have these series of waves going out from the centre. That's happened on the moon. This is exactly what's happened on the Earth. In the Pacific Ocean basin, you have your depressed area, and immediately surrounding the Pacific Ocean basin, you've got the ring of fire surrounded by mountains. You've got this mountainous border, just like you have with Mare Orientale here. Mountainous border around there. On the eastern side, you've got America. And on Western America, you've got your mountains, and then they taper down to the eastern seaboard, which then dips down underneath the Atlantic. You've got your depressed ring area around the Mare Orientale basin here. The Atlantic Ocean forms a depressed area on one side. You've got your Indian Ocean forming a depressed area on the other. And then you come to Europe and Africa, forming the second part of the ring. As you have a look at the whole structure of the situation, you find that the waves would reinforce in the Himalayan mountain area, so you'd have massive upthrusting. It all means that you'd have a tremendous amount of geological work done. You'd have had magmas intruded, the oceans and currents and tidal waves racing to and fro. You would have had a tremendous amount of sediment transported. The prophet Amos, I think it was in chapter 8, said, "Seek him who made the 7 stars and Orion, that makes the day dark with night, that calls for the waters of the sea and pours them out across the face of the earth. The Lord Jehovah is his name." It was God who did it. He caused the waters of the sea to pour across the face of the earth. In fact, as you have a look at the magnitude of the disaster, the size of that Pacific Ocean basin is 4,500 miles across. Put this thing here on the moon in the shade. With the magnitude of that disaster, it's no wonder that your geological sequences have formed. The only wonder is that there are any survivors at all. And if it hadn't been for mercy, the sun, shining through judgment the cloud that produced the rainbow, there would not have been any survivors. God had it in his heart to save Noah. And that's why you and I are here today. So Mr. Dodwell did a bit of further investigation. He thought, well, if Mr. Dodwell's model fits all the facts of factual tilt and accounts for a geological column and all erosion features in the last 4,500 years, there's absolutely no problem with that. It means, therefore, that all the evidence, when taken into account, completely fits the scriptural point of view that the earth is less than 10,000 years old. So if the earth is less than 10,000 years old, what about the rest of the solar system? Let's have a look elsewhere. Here's our unique planet. Let's leave that for a moment and have a look at the moon. We prove that the earth is young. Does the rest of the universe fit into the same pattern? Our next slide shows the moon as seen from space. You can see these massive Mare plains, which are depressed basins caused by the impact of giant meteorites. The moon's origin has always been something of a mystery to science. Formed about the same time as the Earth, all astronomers are agreed. So it should therefore be young. Can we prove that it's young scientifically? Our next slide shows the crater Eratosthenes, again formed by the impact of a meteorite, somewhat smaller than those that form the Great Big Mare Plain. And these craters must have formed in the final phases of the creation process of our solar system, when the debris that was left, the leftovers after creation, rain down on the surface of the planet and the moon, which God has made. Next slide, Peter. It shows you some of the Mare plains on the moon, these dark areas. Lighter areas have got the heavily cratered upland. Now, just as the craters were formed by large chunks of matter raining down onto the moon, there should also have been a fantastic quantity of fine dust, this cosmic dust which we met with the Earth earlier. This cosmic dust as a leftover from creation fell on the moon, and in addition, high energy radiation from cosmic rays should have pulverised the surface. The surface rock should have been pulverised to dust by high energy radiation. If the moon was 4,500 million years old, R.A. Littleton, a very famous astronomer in the Modern Universe published by the Harvard Press, on page 72, said that the dust on the moon should be about 28 miles thick. 28 miles thick. That's if the moon is 4,500 million years old. And Professor Fred Hoyle and Tom Gold and Bondi and a few others said, yes, that must be right, because on these Mare plains, you've got these craters which have just got their walls poking up out of nowhere. They just rise up very suddenly. Fantastic, he said. Hoyle pointed out that this must have been caused entirely by a smothering effect of dust. You can read that in Frontiers of Astronomy in his chapter on the moon. Well, this presented a problem. Next slide. If we're going to send a man to the moon, there's one of the Apollo craft about to descend onto the surface. If you're going to send a man to the moon, what's going to happen when he lands in all that dust? He's going to be smothered. You're going to lose him. You're not going to get your astronaut back. So this was quite a problem, because of course that dust has had no water to settle it or compact it, had no atmosphere to move it around, it's just going to stay put. In his book, Moons and Planets, William Hartman, a consultant for the Jet Propulsion Laboratory in NASA, and a member of Caltech, quite frankly admits that the NASA people spent $1 billion, that's $1,000 million, on trying to settle this problem of the dust on the moon. Is it there or isn't it? According to evolutionary thinking, the dust has very definitely got to be there. But some of the atmospherics people said, oh look, the reflections that we're getting from the moon seem to show it's solid rock. I said, can't be. There's got to be this layer of dust. I should be concentrated there in those great Mare basins, 28 miles of it. So I spent $1 billion trying to decide. And just to be sure, when Apollo 11 landed on the moon, their landing pads had been designed to sit on dust. I said, before you walk out on the surface, test the solidity of the surface with your boot. Stamp it and see what happens, because we don't want you to sink down into the stuff. So all right, that's what Neil Armstrong did. Next slide. There's man's first footprint on the moon. Didn't go down 28 miles. In fact, it went down only a couple of inches. Next slide shows that they could walk about quite safely. Here's their footprints down here, just a little one, without any problem. In fact, they could even drive around. But Armstrong said, I can scuff through the dust with my boot to the solid rock beneath. Next slide shows that they could drive over it with their lunar buggy. There you have it. And just leave little small tracks. Obviously he wasn't a good driver. Other landings have been made on the moon, and all told the thickness of the dust ranged from 1/8 of an inch to 3 inches thick, not 28 miles. If 28 miles were formed in 4,500 million years, in 10,000 years the layer of dust should only be 4 inches. The layer of dust was 3 inches and less, so the moon is less than 10,000 years old. The moon is less than 10,000 years old. That's astounding. for many, many months afterwards, after that first lunar landing. Dust became a dirty word to the NASA astronomers. They've quietly hushed things up and they've said no more about it. They know something's wrong, but they won't admit that it's their time scale. Let's move on to our solar system and have a look at the planet Jupiter. Here's Jupiter, the biggest planet in the solar system, about 88,000 miles in diameter. And its little moon, Io. Io is about the same size as our moon, a little bit smaller in fact. Jupiter is the largest planet, and the heat from Jupiter and Saturn and Venus is 2.5 times what they receive from the Sun. This too is a problem to astronomers. It can't come from a gravitational contraction or radioactive heating because of their internal composition. The only conclusion that astronomers can come to is that Jupiter and Saturn and Venus are still cooling off from the creation process. But to admit that is to admit that they're young objects. And that's unheard of. So let's have a closer look at Io. There's the little moon Io. There's a great big bulk of Jupiter. A great red spot of Jupiter here. How'd you like to live in that sort of environment? Have something to talk about all day long, wouldn't you? Io has an atmosphere. Our moon doesn't. That's a problem to astronomers too. Because if Io has an atmosphere, it means that Io must be less than 10,000 years old, because you can show from the mathematics of the situation that an atmosphere should have evaporated away, because Io's gravitational field is not sufficiently strong to hold it. In addition, there are massive lightning bolts from Jupiter which come and hit Io every so often, quite frequently in fact, and vaporise sodium deposits in some of the salt plains that cover the surface of Io. In fact, when Jupiter and Io are lined up with the Earth, we get massive static radio reception coming from that direction in space, all because of these massive lightning bolts. Now this sort of thing can't have been going on for too long, because these salt deposits would have been completely vaporised and have disappeared by now if this whole thing was 4,500 million years old. And there's another thing too, as shown on our next slide. Io has got 6 active volcanoes. Here's one of them blowing its top up here. It's going about 200 miles up into space. And as a result of this, there's a massive ring of debris in Io's orbit, gas and fine particles. And as a consequence, it means that if this has been going on for 4,500 million years, Io should just about be empty by now inside and just be a hollow shell. But it's not. In fact, it's one of the most dense little planets in the solar system. It's even denser than our moon. So the whole thing points to the fact that the Jupiter-Io system is young. About 10,000 to 100,000 years old at the most. And simply because its upper maximum is 100,000 years doesn't mean to say that it's been existing that long. All these things should have come to their termination in 100,000 years. The Voyager probe to Saturn, our next slide, brought some further problems. The rings of Saturn, as you see there, are small ice-covered rocks from the size of peas to footballs. Now the interesting thing is that the diameter here, or the width across here of the rings, has been steadily increasing. And the gap between the ring and the planet has been decreasing. You've got 3 rings here, the A ring, B ring, and C, the crepe ring, which is distorting the shape of the planet there. That's the crepe ring that comes in around here. And that gap between the rings and the planet has been steadily decreasing since Saturn was first observed. Christian Huygens in 1657 drew many diagrams of Saturn as seen through the telescope. And in Sky and Telescope of July 1960, they pointed out that the rings had very definitely widened, and Shekspyatsky has shown that in 1800 years, ring B, that's this one, in 1800 years' time, this ring would have fallen onto the planet at the rate in which this thing is drifting in. Again, Cassini's division, which is this dark area through here, Cassini pointed out this should be dark because there'd be no particles there due to the pull of the satellites. The satellites are going to throw all the objects from their orbits in this particular area. But when the Voyager craft got out there, what happened? Next slide. Here's Cassini's division in here. As you can see, you've got 1, 2, 3, 4 rings inside the gap. I actually originally programmed Voyager 1 to skip up through the Cassini division and take photographs of the rings on either side. They cancelled that. They would have lost their spacecraft. In addition, the rings turned out to be fixed and undulating. And ring A was twisted around another ring twice. It's not shown on this photograph, but it's actually shown on the photograph coming through from NASA. I'm sorry we haven't got any more recent photographs in colour for you. We had to get these organised pretty quickly. Now gravity would have flattened out the rings in 10,000 to 100,000 years. So obviously the rings are less than 10,000 years old, otherwise they would have flattened. So if the rings are less than 10,000 years old, so is Saturn. And on our next slide, we'll show Saturn and her satellites. It has a giant satellite, Titan, this one over here. And Titan has an atmosphere. And again, that should have disappeared if Titan was anything more than 10,000 years old. So it means that Saturn, plus its rings, plus its satellites, must be less than 10,000 years. So if Jupiter and Saturn and Earth are less than 10,000 years old, the solar system must be less than 10,000 years old. Let's just have a look at some further proof of this. Let's have a look at the age of the comets. There's Morehouse's comet, which went past in 1908. Comets are made up of stony meteoric material frozen together with dust and ice. And the head of the comet is the dirty snowball, if you like. As the comets come in from the outer solar system towards the sun, this snowball melts, and the solar wind, the particles from the sun, push out these particles of gas and dust in a long stream behind the comet head. This is why the comet's tail always pokes away from the sun. There it is in its orbit. Next slide shows the orbit of Halley's comet. As you can see, it comes in very close to the sun and goes a long way away, right out between Neptune and Pluto. This is one of the short period comets, but their orbits are highly elliptical, and because they come close to the sun, there's intense heat and massive tidal forces means that the comets lose their gas and dust and rock. And so comets eventually break up and form a meteor swarm, as our next slide shows. On some occasions, comets have been seen to split into two near the sun and break up. The subsequent time when that comet appeared, Biela's comet, instead of a comet, you had this massive display of meteorites. This is what's left over from the comet. The comets disintegrate. Next one shows Halley's comet in 1910. Now all short period comets like Halley's, you can see the point there of where the snowball is, which forms the nucleus of the comet. All comets like Halley's can be shown to have a lifetime of 10,000 years at a maximum. This is what the astronomer R.A. Littleton pointed out in his book Mysteries of the Solar System on page 110. And he couldn't account for it. If the comets are less than 10,000 years old, and our solar system is 4,500 million years old, where are the comets coming from? Well, they invoked a rather unusual process. Next slide. I said there must be a massive swarm of comets right in the outer limits of the solar system which we can't see. Very conveniently out of the way. And they said every so often when a star passes, this dislodges a particle from its orbit and sends it in towards the sun. It orbits around and comes back and joins the comet cloud. On some instances, some get captured by the planets and stay in a close orbit. Well, you need something like 3 million stars out there to dislodge these comets from their orbits within 3 light years to supply the comets which are seen in the solar system, to maintain our supply. In fact, as you have a look at comets coming in from outer space, their orbits are such that as they come round past the sun, they're not captured by the planets. As you have a look at the orbit statistics, Their orbits are such that they come right out again and are lost to the solar system altogether. So you can't account for your comets by invoking a comet cloud. In fact, the whole theory is self-destructive when you have a look at the orbits of these comets of long period. So on both long period comets and short period comets, you're left with no explanation for your short time scale, unless you're a creationist. That's something which evolutionists don't want to have a look at. So we have a brief look at the origin of our solar system. Next slide. That's the Trifid Nebula. Evolutionists like to invoke the collapse of a cloud of gas and dust like this nebula and claim that the solar system formed out of something like that. But Professor Sir Fred Hoyle and George Gamow both claim that such a cloud will not collapse under its own gravity unless the temperature is between 1 and 5 degrees absolute. But the temperature of all of these interstellar clouds is something like 100 degrees absolute. So it's another impossibility for them to collapse. In fact, you can show that even at 5 degrees absolute, the gas pressure is something like 60 to 100,000 times greater than the G-forces tending to collapse it. And as your cloud collapses, this raises the internal temperature, which re-expands your cloud. So star formation and solar system formation just cannot be forming. Well, they overcome that one rather nicely. They say that perhaps there's been a supernova explosion which pushes the gas together. As you have a look at it, it doesn't really work that way, but in any case you need a star to form a star. And you can't account for your formation of stars that way, not originally. It's a complete impossibility. So as far as the solar system is concerned, there are several problems. Next slide, please. Cameron in 1962, in Sky Telescope of May of that year, was able to show that from the collapse of the dust cloud, you would not get a central condensation forming with the sun in the middle. It just won't happen. You can't have a star forming at all. Now that's bad news for the evolutionists. It means that their theories are hopeless. In addition, a collapsing cloud would go from Pluto's orbit to Venus's orbit in just 6 months, and this is not long enough for the evolutionists to have their planets forming. They need thousands and billions of years for this to happen. So the planets would not accumulate. The only time which it would happen is if you had a creation set of circumstances with God himself acting. The psalmist says, when I consider the stars, the work of thy fingers, God has fashioned them with his own hand. There are several other problems. The old theory for the formation of the solar system is shown on the next slide. This is the stellar sideswipe, a star that's invoked coming close to the sun and drawing off a filament of gas from it. This was the James Jeffreys idea in 1917. And as was pointed out by Spitzer, next slide, it was pointed out by Spitzer in 1939, this stream of gas was going to expand explosively. So your planets just can't form. So the conclusion is that the sun and the solar system could not have formed by proposed evolutionary processes. You need some creative force to produce it. Well, let's now have a look at the age of our galaxy. We begin by having a look at the age of the open clusters of stars, such as the Pleiades. I mentioned the Pleiades this afternoon. They're a bound cluster. They hang together in space. They're not disrupting. In that sense, they're unique. Open clusters of stars all have a common origin. And according to astronomy, they're all young, population 1 objects. From the scriptural point of view, they must have formed on their 4th day. Hoyle in Frontiers of Astronomy, page 238, pointed out that the Pleiades are unique because they're not disrupting. Most clusters like the next one, the Psi Persei cluster, which there's, just to get the number of stars in that one, there's quite a few hundred. But that's actually a disrupting cluster. That cluster's expanding at the rate of 30 kilometres per second. Its maximum age is 100,000 years. In 100,000 years, that cluster will have completely disappeared. So its age must be far, far less than that. Its age must therefore be something between 10,000 years or several thousand years and 100,000. This is standard for all of the open clusters. Now in the Orion Nebula, which is our next slide, Dr. Peter van der Waart has proved that the age of one cluster of stars in that constellation, in that part of the constellation of Orion, is less than 10,000 years. He's able to prove it. Now all these stars form together. The minimum age, therefore, of these clusters of stars must be common to all. If you've got something which is less than 100,000 years, less than 50,000 years, and less than 10,000 years, and you know they're all formed at the same time, the minimum age, 10,000 years, must be also the minimum age for the whole lot. So if this cluster of stars in the Orion Nebula is less than 10,000 years, it means that the whole of the open clusters of stars that we have in our galaxy are less than 10,000 years. Because no new star clusters are forming. We've just shown that. Those clouds of gas and dust just don't collapse. And so we turn our attention to the age of the globular clusters. These globular clusters of stars are situated above and below the galaxy like a massive halo, like a massive cloud. These globular clusters have 100,000 to 1,000,000 stars all packed into them. They're so close together that the stars are only light hours apart instead of the light years which normally separate the stars. In fact, if there are any planets around any of those stars, there'd be no such a thing as night or day. The sky would be a continuous blaze of multicoloured light. Fascinating. These are the morning stars. These are the oldest. Astronomers say that these globular clusters are the oldest astronomical objects. 11,000 million years old. That's interesting. God says he formed them on the first day in the morning. In the morning of the first day, when the morning stars sang together. The next cluster is the M13 Hercules cluster. There it is in colour for you. Now 1,000,000 stars all packed together like this all have a solar wind, just like the sun. And gas would build up in the cluster as a result of the solar wind. There should be, after 1,000,000 years, there should be 500 times the mass of the sun, mass of gas in there, after 1,000,000 years, just from the solar wind from these stars. What's happened? No gas has been discovered. Astronomers have been horrified. In fact, in 100,000 years there'd be 50 times the mass of the sun in gas. And that is easily detectable as well. So these globular clusters are much less than 100,000 years old. Now again, as we show on our next slide, because of the gravitational pull of the galaxy, these globular clusters should distort their shape if they've been there for any length of time. And as you can see, they're all absolutely circular, spherical in shape. They haven't distorted at all. They should be elongated like footballs if they've been there for 4,500 million years. The gravity pull of the nucleus of our galaxy should have distorted them. Harwood pointed this out in Astrophysical Concepts, page 43. And again, the next slide shows that same cluster in colour, M3. Some globular clusters are moving at such a high speed that they would have escaped completely from the galaxy in 1,000,000 years. In other words, our galaxy just is not holding these clusters to itself at all. Now that's a real problem. They should have disappeared within 1,000,000 years. So obviously, because they're still there, they're much, much less than 1,000,000 years old. From the fact that there's no gas there, they're much, much less than 100,000 years old. Globular clusters must therefore be somewhere between 10,000 and 100,000 years old. And these are the oldest astronomical objects. Well, let's have a look at the age of the clusters of galaxies. If the galaxy itself is less than 10,000 to 100,000 years old, what about the clusters of galaxies? Now the galaxies tend to occur in clusters by like company, just like human beings. This is our neighbour in space, the Andromeda Nebula, M31. A spiral nebula, you can just trace out the spiral arms around here with this amount of gas, and here's some of the fainter parts of the arms out here, around there like that. Our local group of galaxies has something like 25 members. Now in galaxies in clusters, we find that, next slide, many of them have bridges of gas between them. This is vastly magnified, as you can see. And here's the stream of gas and stars in this bridge. Now the motions of these individual galaxies that the bridge is linking is something like 500,000 kilometres per second. They can't have been there for long, otherwise that bridge would have been broken. And yet 10% of these bridges show very old stars, red ones. This is a real puzzle to astronomers. If you project them back, in 2 million years, those things would have been touching. If you go back in time. Obviously, they need not have been created in a touching condition. They could have been created separated, with some of the bridge already in existence. So that brings the age back to less than 1 million years. Probably only hundreds of thousands, at the most. Again, as we have a look at a cluster of galaxies, the Leo cluster. The motions of galaxies within this cluster, you can see quite a few galaxies here. All these fuzzy objects are galaxies. You've got one there, got one here, an elongated one over there, another one up there, another lot over here. Galaxies everywhere there. Clusters of galaxies right throughout space. The motions of galaxies within these clusters is high. In fact, galaxies would seem to evaporate from these clusters at a very high rate. These clusters can only last for about 2 million years at the observed rate of expansion, and then none of the clusters would be left. And astronomers say, well, look, this is impossible. It just can't happen. And it's been called the missing mass problem. They say the only way we can get those clusters to hang together is if there was more mass in these clusters than we are observing. And astronomers have looked for mass everywhere. They've looked high and low for it. Gas clouds, dust clouds, invisible mass, black holes, all sorts of things. And they've come across an impasse. In fact, B. Margan, in his article Missing Mass in the Mercury of January 75 on page 6, says we have reached an impasse. Inevitably, some cherished scientific principle must fall because of this missing mass problem. That's interesting, isn't it? They look high and low for the mass and just cannot find it. We've reached an impasse, they say. Because these clusters of galaxies are young, the whole universe must be young, because the whole universe is made up of similar clusters. And incidentally, the Big Bang won't work either, because when you have the whole thing expanding out radially from a central point, there is absolutely no way in which condensation can form, in which particles can condense and form planets. So the Big Bang theory is in trouble. But what's the evidence for an old universe? Let's have a look at radioactive dating. They used the decay of uranium, thorium and lead as their means of dating of meteorites and elements and rocks. Now many discordant dates come in. I haven't time to go through this in detail. And there are some very anomalous dates which have been derived as well. Just to give you one example. A lava flow was outpoured in Hawaii in 1801 AD. Just a couple of hundred years ago. Recently, it was dated, and the ages given by radiometric dating ranged from 160 million years to 3,000 million years. And yet that lava was outpoured in 1801 AD. Now this shows you the problem that we've got with radiometric dating. Peter's going to handle that question more fully tomorrow. But nevertheless, there is this hard core of dates which does seem to indicate great age. How can we overcome that? We'll have a look at that in just a minute. The next slide shows M31 again. The apparent ages of the stars are based on their nuclear fuel cycles. And again, the apparent age of the universe is also based on the total distance that light has travelled. This is a problem. The outer limits of the universe are 10,000 million light years away. It's taken light 10,000 million years to get here, travelling at its present speed. So obviously the universe must be 10,000 million years old. Or is it? I took this problem to the Creator on January the 11th, 1973, and I received a reply which astounded me. He said to me, "Why do you assume that the speed of light has remained constant?" I was astounded. This went against everything which I had ever been taught in high school and university. It's only just in recent times, over the last year and a half, that I've been able to research this position. And it's an astounding thing that the speed of light has changed. Let's have a look at our next slide. When I talk about c, I mean the speed of light. C is the shorthand symbolism that we use for the speed of light in physics. And the first measurement of the speed of light was done by the Danish astronomer Romer in 1675. And the speed that he came up with was 301,300 kilometres per second. In fact, this is a modern determination using Romer's data. They've got Romer's logbook and found out that they actually tried to reduce the speed of light to the present day using Romer's data, and they found they couldn't. This was the minimum that they could reduce it to, 301,300 kilometres per second. And every observation after that date has shown the speed of light dropping right down until the speed that we have today is 299,792.45 kilometres per second, a drop of 1,507 kilometres per second in 300 years. Next slide. I went to a friend of mine who's a mathematician at Flinders University, and he used the DEC 10 computer at Flinders. We used the observed values of the speed of light and tried to come up with a curve which would fit these values. We tried umpteen dozen of them before we struck the right one. And when we struck the right one, here's the predicted values over here from the curve, here's the observed values, and here's the difference, observed minus predicted. And you'll notice that the observed minus predicted values are always within the limits of experimental error of the observed values. In fact, we haven't got it down here. I haven't got the last slide with the last few values from 1949. But right down in this area here, from 1949 on, the observed minus predicted becomes very, very small because the observations became extremely accurate. So the speed of light very definitely has changed. So we found our decay curve. Next slide. Here's our decay curve for the speed of light. The date of origin at which this curve becomes almost vertical is 4040 BC, 4040 BC. The speed of light at that date, which must have been the speed of light at the time of creation, was 5 by 10 to the 11th faster than what it is today. In other words, at the time of creation, the speed of light must have been 500,000 million times faster than what it is today. And again, this is based entirely on observations. From the observations down here, it's a distinct mathematical curve. If we can have the next slide, Peter. We've blown up the area between 400 BC and the present. It shows you the difference as it drops down. It looks far better on that one. We're using a logarithmic scale on the other graph, which means it was going up in steps of 10. This isn't. It's going up just normally. And in fact, the date of origin is extremely sensitive to the observations. If we put our date of origin too far back, this curve would have come in below the set of observations. If we brought it too far forward, this curve would have come in above the set of observations. And so we can get an accurate date for the creation of the universe simply from the observations. 4040 BC, just when the Bible says it was. Next slide shows the accuracy of fit to the data. Here's the first two values, here are the other values down here. As you see, this is a straight line with a very small clustering. In fact, R squared, the coefficient of determination, it shows how well your fit is to your data, was 1. If it's 1, it's perfect. Ours was 1 to 9 significant figures. You can't expect it much more perfect than that. The next one shows the error bars and the observations. It's just not possible to take a line from the bottom of the first observation in error to the top of one of the error bars down here. That comes right across there like that. Obviously, the speed of light has decayed. Something very definitely has not been taken into account in Einstein's theory. The final slide returns us to the Earth while we discuss this in just a little more detail. Date of origin, as I said, is 4040 BC. During creation week, and I've assumed that the speed of light has remained constant throughout creation week because I don't see why God could allow it to decay while his creative force was in action. The speed of light was 5 by 10 to the 11th faster. Therefore, in 1 week, the distance that light would have travelled is 10,000 million light years at that speed. In 1 week, light would have travelled 10,000 million light years. So Adam, there, on the 7th day, if he had the same equipment that we had and looked out to the universe, he would see exactly what we see. He'd be able to see to the limit of the universe just as we would. There's no problem there. So that fact can be completely harmonised with a young universe. The distance of the galaxies and the distance that light has travelled is no problem. Again, radioactive decay rates depend on the speed of light. I won't go into all the ramifications of this now, but with a higher value for the speed of light, the faster the decay. The half-life becomes smaller, in other words, in inverse proportion to the speed of light. So therefore, the half-life of uranium-238 today is 4,500 million years. But that was speeded up 5 by 10 to the 11th time at the time of creation. And uranium, instead of having a half-life of 4,500 million years at the time of creation, had a half-life of 3.29 days. In other words, in the basement rocks in your geological column, you would have this built-in appearance of age with all of your radioactive data. In 3.29 days, your uranium would have decayed to half of the quantity that it had originally at the time of creation. And it's on these facts that science bases their dates. So radiometric data can be shown to simply be a proof of a young creation with a higher value for the speed of light at the time of creation. In fact, as you measure the ages of the basement rocks from the uplift on the 3rd day, you would expect from the theory of the situation with a higher value for the speed of light for these rocks to date somewhere between 4 billion years to 1.8 billion years. This is exactly what's discovered in geology. It's exactly there. This is why you're getting these vast apparent ages, simply because the speed of light was higher at the time of creation. And again, the rate of burning of a star's fuel turns out, as you have a look at the mathematics of the situation, to be proportional to the speed of light. But as you have a look at its luminosity, the luminosity of a star should have been constant. There are several cancelling factors to produce this result. So it means that the sun's light output was constant, but it was burning its fuel in proportion to the speed of light. So therefore, in 1 day, with the speed of light 5 by 10 to the 11th faster, it would have burnt 5 by 10 to the 11th days equivalent of fuel on today's basis. And this is why the sun appears so old. In fact, the sun would have aged 5,000 million years at the end of creation week, from its creation on the 4th day. And those morning stars, which lit up on the 1st day, would appear to be something like 10,000 to 11,000 million years old, because they burnt their fuel so rapidly with a higher value than the speed of light. This gives us the exact apparent ages that astronomy comes up with, and the exact apparent age difference between the stars. One final thing, it appears, and I'm not 100% sure about this, we're still investigating the situation, the redshift of the spectral lines of the galaxies is due, it would have seemed, to the change in the speed of light, not due to the expansion of the universe. In fact, it appears that the universe may in fact be contracting. In fact, as you have a look at some of the equations governing the behaviour of the universe, it seems that the universe is very close to a black hole stage, in which it's going to collapse catastrophically. This is what Jesus said, and in which the Scriptures said is going to happen right at the end time. At the end of the millennium, there's the resurrection of the unrighteous dead, called before God's throne. And the heavens and the earth pass away with a fearful noise and great heat. And the elements are burnt up with fervent heat. This is exactly what would happen. The universe collapses in on itself in a black hole situation. We've got the proof of this from the speed of light. Nevertheless, we look for a new heaven and a new earth wherein dwelleth righteousness. The only question is, my friends, are you going to be in that new heaven and new earth? Because you won't get there unless you've accepted Christ as your own personal Saviour. Thank you very much.